Let me get back to the actual 12. All right, so that's just, you know, lists or ranges. And I think the other thing we want to mention is that we can actually go through and we can generate lists in a negative direction by using a negative increment and walking backwards from some value. We can even make this from positive 10 or something and walk backwards. Okay, so we have a lot of control with ranges to generate indices for loops. Okay, and so, you know, a very easy example is, let's start out with our planets. Right, we can do something like generate a list of planets. Right, so now our planets has the 9 planets, not the 8 planets. Okay, we can get off that horse. I'm very sad about Pluto. We can say for I in range length of planets, and that just generates the numbers between 0 and 8. We can print I, and we can print planets sub I. Right, and this will tell us what order the planets are in and their index, right, 0, 1 through 8. And we can do different things. We can, for example, if we wanted, we can change this to give, you know, let's say we think there's 9 planets, not 0 through 8. We want to turn this into something that everybody can understand. We can offset our I by 1, and that should do the same thing, except it'll give us 1 through 9 instead of 0 through 8. If we want to go backwards, we just have to write a backwards range. So if we want to go backwards, we want to start with length of planets -1. We want to go all the way back to 0. So -1, I think. And then we want to do -1. And hopefully that'll go all the way backwards, right? So now we've started at index 8, length of planets -1. We stop at 0, right? 1 before -1, and we walk backwards. So we give them 9 through 1. And if we want to do like every other planet, for example, we don't like all the even planets or the odd planets. The odd planets are odd. We just don't have any desire to mess with them. We can say by 2. Give it a starting location of 0. By 2. Get rid of all those odd. And I did it again. Get rid of all those. There we go. Get rid of all those odd planets, right? And now we're just going to generate Mercury, which is 0, Earth, which is 2, Jupiter, which is 4, Uranus, which is 6, and Pluto, which is at index 8. Okay, so we can play with these and generate the loop variables we need. Way back in the far beyond, we talked, I think this was lecture 1. We talked about triple doubles code. If you guys remember, this just went through, right? This went through and it looked at all of the words in the English dictionary. We actually read in a dictionary from a website. And what we were looking for was all any word that has 3 doubles in a row. And I told you by the time we got about halfway through this course, you would understand what this part actually meant. So, you know, we can run this and we should get, hopefully, bookkeeping again, not beekeeping. Bookkeeping again, bookkeepings. And what we said was, you know, this was an example of not wanting to walk through all the letters. And the reason is, when we're looking at our words, right, we're always looking 5 letters ahead. So we can say book keeper, right? Well, when we're sitting at the start of our sequence being here, we're actually accessing here, 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 and here, right? So we're at the current location plus 1, 2, 3, 4, 5. So as we walk through this, right, when we're on the O, we're looking up through the P. And when we're looking at the K, we're up through the E. And when we're at the second K, we're all the way up to the R. If we were to continue, we would walk off the end of the word, right? And that would give us an error. So this allows us, right? So instead of walking all the way off the end of the loop, off the end of the word, down here where we're evaluating 5 characters ahead of where we currently are, we can use these control, we can control the range we use so that we only walk up to the end of the word and not actually beyond it. And you can see down here, right, here's the +5, and that has to be matched by a -5 to keep us within the word boundaries. What's the difference between using range length of object versus using enumerate? Enumerate gives you both the index and the value. It's acceptable. This is a little bit cleaner from the standpoint of trying to learn what's actually going on. Enumerate essentially does this inside itself. So, you can write an enumerate function using using a for, for in. So that's a for in a range. So, the idea is this is closer to what we actually want you guys looking at so that you understand what's going on versus something higher level where you don't have to actually have the understanding to use it. So enumerate is fine. This is cleaner, easier to explain, and works just as well. Okay. All right. Let's. We're hitting a lot of topics today. I know that this seems kind of like a scattered day, and it is to an extent. But these are all complications that we've mentioned, but we haven't necessarily. We want to make sure that you are kind of grasping them, or that you get reinforced now that you know a little bit more about loops. We took up a lot of time on the exam stuff, and we took up a lot of time on the random walk. So I'm going to kind of skip these practice ones. Why don't you guys take this as a homework, informal homework. We're not going to grade this. We're not going to collect it. But take a look at these, and I will answer these. I'll answer questions on these at the start of next lecture if you have any. Okay, just you'll have to remind me because I won't remember. But please do remind me, and I will take a look at them there. Oops, shoot. Okay. Here's where we kind of get into some of the complications. So oftentimes we're given a list. In this class, you will be given it at least once a semester. Now we're given a list, and we have to do something among the points on the list. And here are the important things, right? So we have a list of points, right? And these are, let's say these are points in a Cartesian plane, and we want to find in points. And we want to find which point is closest. Now here's a couple of things to consider. If we want closest points, right? We want to walk through this, and we want to find which two of these points are the closest. Well, if we just calculate the distance between 1, 5 and everybody, right? The distance between 1, 5 and 1, 5 is going to be 0. So unless there's another 1, 5 in this series, we actually want to skip 1, 5. right? We don't want to actually compare something against itself. So that's the first thing. The second thing to note is that the distance between 1, 5 and 13.59 is the same as the distance between 13.59 and 1, 5. So it's really a waste, right? As we go through this, what we're going to do is we're going to take 1, 5 and we're going to calculate the distance to each one of these other values, not against itself. And then we're going to take 13.59, and we don't want to start at 1, 5 because we've already calculated that. If that were a minimum, we've already got that in, right? Instead, we want to start here. We don't want to compare it. We don't want to calculate the distance to this 1, 5. We don't want to calculate the distance to itself because the distance to itself is going to be 0. We just want to start walking here. Okay, so let's kind of, and we have this code, by the way, is in this code in a more formal form is here in our code developed in class. Right, so you can see, you know, a very formal way of doing this here with all of the nice comments in and nicely structured. I don't know if I'm going to get that nice today just because we are in a little bit of a rush for time. But let's start off. The first thing we need to be able to do is we know we have to be able to calculate a distance between 2 points, and we'll call that distance P1, P2. And, you know, this is, we'll use the L squared distance or the L2 distance. So we want to return P1 sub 0 minus P2 sub 0. We want to return the square of that plus P1 sub 1 minus P2 sub 1, P2 sub 1 squared, and then we'll just return the 0.5 power of that, I think, of that sum. I think that's essentially the distance formula. Right? So that's going to give us our distance. So now let's start writing our loop. We'll start off by setting our points to be this. Right? And now what we want to do is we want to kind of figure out an initial distance. So we'll start off, our initial distance is going to be we'll call it close equals and we'll just arbitrarily seed this with points sub 0. So we know that this is actually a real distance, and since it's the first distance that we find, we can set up our closest distance to be the distance between points 0 and points 1. And we can say, you know, L1 equals 0, L2 equals 1, and these will be, right, this says that this is the distance between point 0 and point 1. So we've kind of seeded our closest points formula, and now we can say for I'll use I hate using I, but I've run out of thoughts. For I in length points, right? So this is going to start us at right? This is going to start us at 1, 5, and it's going to walk us through all of the tuples, all of the point coordinates in our array points, picking out one at a time, right? So we can even do this. Let's just print points sub I, right? So we're going to walk through 0 to the length of points minus 1, and we can just print that out, right? So this should give us something. Int object is not iterable. Oh, for range. Sorry. We do need the range. Right, this just walks us through 1, 5, 13.59, 10.5, etc. Okay, so that worked pretty good. We're walking through. We want to do that. Now, what do we actually want to do with this? Well, for every point we see, right, 1, 5, we want to walk through and compare that against everybody else. So we'll use another loop counter j, and we'll say for j in range something. And it's going to end at length of points because we don't want to walk off our list. But let's figure out what we actually want to start at. Well, when we're on item 0, when I is 0, we want to start at item 1. When I is at item 1, we want to start at item 2. And in each case, we want to continue to walk to the end of the list. Right? So when I is at item 2, we want to start at item 3 and walk to the end of the list. So, really what we want to do here is every time I is at a value, we want to start one higher than that value. If we start at I, right, then we're going to compare it against itself. We know that distance is going to come out to be 0. So we don't want to start at I. We don't want to start before I, because then not only are we going to hit I, but we're also going to hit values we've already calculated. That's just a waste of processing. So we'll start, one beyond that. And once we've done that, now we can say if, let's see, we'll say d equals dist. And we want the distance between the first point I, and the second point, points j. And then we just want to say simply, if d less than close, now we want to mark this as the next closest point. Yeah, we'll do that by saying, close equals d. So we'll move the goal. Right now you have to beat d instead of our original guess, and we'll say L1 equals I, lower value, and L2 equals j, the higher value. And then at the end we can just print out something like print something like this, distance and this is going to be a float, so we can do something like :2f dot format points sub I points sub L1 and L2. That's where we're saving the closest ones. And I think it was close, right? And we should be able to use a slash character to bring that down. Okay, so that's essentially the code, one version of the code to walk through this. And it tells us that the closest ones are 10.5 and 8.2, and they are 3.61 away. I'm inclined to believe that. At least looks reasonable to me. Okay, that's a way to do this without using an auxiliary list. I think that we call out in the problem that you can also do this using a list. If that's the case, we can do something like, I'm not going to bother keeping the indices. We can do that as well. But I'm just going to start a new list called close. Here, I'm just going to say close.append, right? So now we're just creating a list of all the distances. And we don't have to have this if statement anymore because we're just doing a list. And now we can say print and we'll just print out the minimum distance. And we can do this very easily because close is now a list, so we can do the minimum of the list and just get rid of everything else. And hopefully this will give us the same answer. I'm missing a parenthesis. Okay. Right, and if you want to look, if you want to look at this example here, right, this is essentially what we're doing. This is the first, closest points to is the first way of doing it without an auxiliary list, and then closest points, oh, it just does the same thing. Okay, so what they're using is they're using a list of lists. Let's throw that together just quickly. When you do a list of lists and you do a min, it actually works off the first value. So we will make a list of lists where the first value is our distance function. The second value is I. The third value is j. And now we'll close our list. So now we should have at the end, this should be a list of lists. Let's see what this does. Oops. Point to F doesn't work, but that should work. There we go. So now we're getting 3.61 essentially, and it's between points 2 and points 3. Points 2 is 0, 1, 2. Our 10, 5, and 8, 2 is our points 3. So it's giving us the same value. So this is an alternate way of doing it that allows us to, we get rid of all the if statements and all the involved logic, but what we do is we do have to use an auxiliary list, and we do have to append onto there. All right, I've got a little bit of time. So that's, make sure you understand this stuff. That's the nested loops part of our discussion. I'm in the wrong window. I'm in the window I can see, not in the window you can see. There we go. Okay. I think the last thing that we're probably going to get to is how to handle lists of lists. So we just generated a list of lists. So the thing to keep in mind, and let's do that here. This is pretty complete code, so we don't have this in the coding file. But this is going to generate, and we've talked about this a couple of times right now, temps at sites. Like, let's say this is a set of temperatures. Each one of these rows corresponds to a set of temperatures from a specific location. And each column, right, 1212, 1325, is a measurement at a specific time. And you'll notice that these lists can be different lengths, right? It's not the case that they have to be the same length. When you look at this, it's a list of lists. And if you look at the 0th one, right, if you have a list of lists, the 0th element of that list of lists is going to be a list. And the first element is as well, and the second, and so on. So it's pretty easy, right? So if you want to access the third element of the third row, right, 0, 1, 2, well, that would be element 2, 2, right? And that should be 24.3, right? So you count down, you pull out 0, 1, 2, and then you start 0, 1, 2, right? And the key is that as we go through this list, let's say for L in temps at sites, print L, right, what gets returned is actually just a list, and anything you want to calculate on that list can be calculated. This is just another list that you can use, and you can either throw this into another for loop, right? We can come down here and we can say for val in L, right? And now we can access each one of those values individually, or we can do anything else we want with this. So let's say we want to calculate we want to calculate the average temperature for each one of these sites, right? Well, we know these are temperature readings, so we know that to calculate the, let me kill this for a second, right? We know that to calculate the average of a list, it's just the, there we go. It's just the sum of the values divided by the length of the list. So we can come in here and we can say for L in temps at sites, and let's say we're going to keep a list of all the averages. We can say averages.append sum L, right? This is just for that specific list. That's just the sum of all the values divided by length of L, right? And that's just going to append for us onto this list the averages. At the end, averages will have the averages of all the sites, right? Now if we want to find the minimum, we can say min of averages. $11.735. We can look at the max. And if we want to find out the index, we can say, of the site, we can say L.index min averages.index, right? We want to look at the index of the lowest average. So min averages gets us the smallest one, and index tells us what the index was. So it's the smallest one is the first one, and if we look at the max, that would be the second one, 24.6. Okay. So that's just a little tutorial on working with lists of lists. I think we are just about out of time. I do want to just briefly mention a couple of things. Well, I want to mention break and continue. And I'll hit these again just at the end of, or just at the start of the next lecture. But break and continue allow us to break out of a loop. So this while loop is actually an infinite loop, right? While true can never be anything other than true. But we want to stop our input when we get a 0. So what we can do is we can look at our value x, and in the case that x is a 0, we execute a break. And what the break does is it takes us to the next statement immediately outside of the loop, right? So this is the loop body, when we hit the break, it's going to bring us down to this sum, and it's going to print the sum. So we'll do a 7. We'll add that in. We'll do a 45. We'll add that in. We'll do a 0. Now we're going to come down, and we're going to hit this if x equals 0. That'll break us, and it'll come down and hit the print sum, right? And it'll print the 52. So a break is a way to get out of a loop. A continue is a way to skip the rest of a loop. So it's almost like a break, except it just says go back to the top of the loop instead of skip out of the loop. So we can come in here, and I'll do for item in my list. What is my list? I don't even think we have my list. Okay. We'll just give us some values. Okay, and now when we look at this, what this is going to do is it's going to say for item in my list, if item is less than 0, continue, otherwise it's going to print item. So what this should print is it should print 0 through 7. Every time we hit a value that makes this if statement true, we're going to hit this continue. The continue skips the rest of the loop and just goes up to the top. So this should print the numbers from 0 through 6. Sorry, 0 through 6. Range goes up to, but not over. All right, so those are two things that you can use on while loops. Yeah, we'll get into this other thing later. I'm not going to keep you any later than this. But just keep these in mind. And also keep in mind that when you're using a break and a continue, there is always a way that doesn't need a break or continue. So use them sparingly. Generally, what we like to see is if you're using them, do a test like this at the start of your loop. Do a test like this at the start of your loop, after you have the data you need, and then execute a break. Don't have multiple breaks. Don't have multiple continues. It goes against code styling. It makes things harder to follow. So I think that's all we have for today. I have a meeting.